Okay, I've got another hard Sudoku for you. I'll edit this one down. We won't have too much humming and hawing. If you want to see me going through the decisions more slowly, you can watch it on the linked video, which is also on the same playlist, puzzles playlist. So on this one, if I have any sort of decision processes that don't get anywhere, I'll cut those out. It doesn't mean I'll actually go through the thing faster, because I'm not fast going through these, and that's why I hope this is useful for you to watch. First thing I do when I look at a Sudoku is I go through the numbers from 1 to 9, and I look for this. So we've got three of everything. In Sudoku, you got 3 of everything, right? You got 3 rows, you got 3 columns, you got 3 blocks of 3. So going across here, you have a block of 3 that's got the 1 in, which means these 2 blocks of 3 can't have the 1 in. You've got this block of 3 having the 1 in, which means these 2 can't have it in. And likewise with the squares. This one is in this square, this one is in this square, which means there can only be 1 1 in this square. So there can only be 1 1 in this square, there can only be 1 1 in this row, and this row. What does that mean? It means that this row has to have a 1 in, can't be in this square, can't be in this square, so it's here. Okay, so just to show you that basic principle of Sudoku quickly, I won't be labouring the point because most of you know it already. Some of you are just watching though to find out how the hell to do a hard Sudoku. I'll show you. Now we got the same thing here. We got that one. This square has it in that third. This square has the one in that third, which means this square has to have it in that third. So I always think of these in their thirds, these squares. Parallels. Parallel thirds. Sounds like I'm talking about music. So now look at this one here. We've immediately got a block of 3s. This is very useful. Where you have a block of 3 like this and it's not got that 1 in it, that immediately tells us it's going to be in this side. Yep, it can't be that side. It can't be in this one that it's in. So it immediately tells us it's in that side, which also means that where you see the block of 3 without that number in it next to it, it means that that is the line it'll be in on the remaining square. Yeah, because it's got to be on that line on that square, so those 2 are taken care of. It means it's got to be in that line on the remaining square. So you can immediately go, dush, ooh, not there, so therefore there, and then see there's a 1 there, so we know it's there. You can do that. However, on this side, there's actually 2 squares it can be, and that's where we do our little tiny ones in the corners. And what we're trying to hope for is that another tiny number will appear in those 2 squares at some point. And those 2 tiny numbers for 2 squares, only 2 squares that they can bear in, only 2 numbers, and then those squares are immediately taken away effectively from the calculation of the remaining numbers. Going across here now, we've got 1, 1, which means it's the middle one for this one, and that column is knocked out, so therefore we can do our 2 little ones. They're like that for those 2 squares. So a lot done, and we've only done the ones. 2, 2, 2. That's going to be like, oh no, there's 1 down there, so that's a big 2 there. So 2, 2, 2, 2, 2, 2, and now we crisscross and cross-reference. We go across with that 2 there, we come down with that 2 there, and that gives us only 2 squares remaining, so we can do our baby ones. Same here, 2 across there, 2 down there, gives us a big 2 there. 2, 2, that means the middle one has the 2 in, there's already a 2 there, so we can do baby 2s there. And finally, we've got a crisscross there, that 2 there, that 2 at the top doesn't affect it, but in any case, it's just baby 2s here. And one of the other things that these baby numbers do is that these 2 2s here mean that there is a 2, that the 2 that's in this row, now just looking at the whole row here, because these pair of 2s doesn't just belong to this square, it also belongs to this whole row. It means that this row's 2 must be that one or that one, right? Because that's an alternative. That's why we've inked them in baby. Well, that means that it could not be the top one of these 2, because if it were the top one of these 2, where would the 2 be in this square? It can't be anywhere. See? Can't be there because of that. Can't be there because of that. Must be there or there. So if we had a 2 there, that wouldn't be possible either. So we wouldn't be able to put any 2 anywhere in that square. So we have actually solved this pair by putting that little pair in there. Because that covers the whole row. So we can ink that one in there and cross that one out. And then once we've inked it in, we can go upwards again and just check it upwards. We might get more information, more possibilities. Once you get to this stage, it should almost be possible to solve the number, unless you get a square situation, which we've got. So you've got a little square here, which means that as soon as we solve any one of these 2's, the other will solve. Because if it's that one, it has to be the diagonal one in there. And if it's that one, it has to be the diagonal one there. Otherwise, it'll be in line with it. Yeah. So if it's that one, it can't be that one. So it has to be the diagonal one. So when you have a situation where you've got these little pairs and they line up like this in a square, sort of big square like that, then you know it's going to be immediately solved when you've solved one of those numbers. And that could be solved through some other logic. Okay, right. Now then, 3's. There's only one 3 in this puzzle. It's there. 4, 4, 4. Got baby 4's here. 4, 4, 4. Let's do a cross reference. 4 and 4. That gives us actually those 2. Gives us those 2. Cross referencing that 4 with that 4 takes the whole cross away of 4's. And this one's the middle one, so again it's going to be badunk, badunk, but we've got nothing here to help. We can do cross reference here. That's blocked out. That's blocked out, leaves us with 3, so that's no good. Okay, so I think the 4's are done. 5, 5, and babies go here. 5, 5, baby 5's here. Nothing else. Nope, now for the 6's. 6. Not many 6's in this puzzle. Looks like the only ones we've got is these 2 here, so we cross-reference it by looking up and across. Gives us 3 numbers remaining, so that's no good. And down and across still gives us 3, so it's no good. 7, 7, 7. Cross-reference. No cross-references because they're all in a row. We still could end up with 2 squares somewhere only, but we don't. Like here, we could have done possibly, but they're these 2, so they're not next to each other. They're not in parallel to it. They're not in line with each other in any way. They have to be in line to do the baby numbers. So now that we go to your 8's, 8 cross references here like that to give us a pair of 8's here. So you can't have an 8 there, can't have an 8 there, so they're there. Oh no, sorry, there's an 8 there, so we've solved the 8 as being that one there. 8, 8, which means that this one will be one of those 2. Which means that the middle one will have to be in that square or that square. We might have had information here to block out if that 8 had been there, say. That would have blocked out that one, the middle one would have been there, and we would have been able to do more. But we can't. Here's a cross-reference here with this 8 here and this 8 here, but it only gives us 3 remaining squares, so it's no good. Another cross-reference here gives us 3 squares, so it's no good. Right, now for the 9's, 9, 9, 9. 9, again, we've got the 3 in a row here situation, so that 9 can't be there, so it must be in the middle ones here. So we can put in the babies, 9, 9, and then this. Think of it like a pool cue, I always do. So I go 9, can't be that one, so that pool cue knocks it down to there. And the 9's are here. But we've got 8's here as well, so that's given us what I call a slash square. 8's or 9's in those 2, fully taken care of. So we can immediately now, I think that's all we can do now with just the basic idea of looking at the 3's. So now to go on to the second stage of this, we will come back and do that from time to time. Again, that whole thing of 1, 1, and then 1 there. We will do that again. But for now, that's the end of the main stage. We've gone around the numbers once. So now we look at 8, 9 here. So we've got, and now what I do is I point to the numbers one by one, and I say only aloud the numbers that I can't point at, that aren't there. So I go 6, 7, 6, 7, right? And then I listen, play back in my ears what I said, 6, 7. I heard myself say 6, 7, so that goes in there and there. We've got more slash squares. This will help. It will help in ways you don't know yet. That's how it is. That's Sudoku for you. And looking at this line here, this column, I should say, you see we've got the pair of 9s there. That means that the 9s are taken care of. So any remaining squares that need to be calculated, the 9s, for the purposes of this column, are up here. They can't be anywhere else. They must be in one of those two. So we can do the same thing again. We can go 3, 4, 6, 7. So it's 3, 6, 7. So 3, 6, 7. So this is 3, 6, 7. Can't knock out the 3, the 6, or the 7 with any surrounding numbers or anything in the line. So we can't write in. We only write in when there's an alternative. But look what we've got here. This is solved, this column. And you're saying, how, Aaron? How's it solved? It's solved because we've got 8, 9 alternative, 8, 9 alternative. So for the purposes of this column, 8 and 9 are solved because they will be in these two squares. So we again can go 6. So it was 6. That's the remaining one. Simple as that. We can do some cross references. Crossing the 6 with that 6 there gives us an L. It's no good, but it does tell us that the 6 is in the top half of that square. But I'm not going to put it in, actually. I'm not going to. We could silently have a look at it. We could go, because we've got the 1s here, we've got the 2s, we've got the 5, we've got the 9. We could say that we've also got the 6 if we only think of these top squares. And that will leave us with 3, 4, 7, and 8. So 3, 4, 7, 8. Let's go to the bottom squares and just do 3, 4, 7, 8. Well, there's the 4, 7, so that's a 3, 8 slash square straight away. 3, 4, 7, 8. 3, 4, 7, 8. Yep. Only those, but it gave us a slash square, you see. And that may help us later. It will help us later. Everything helps you in Sudoku, everything you do. Look how much is in this column. This is supposed to be hard. 1, 2, so we'll do it again. Count silently with the numbers that are there, out loud with the ones that are not. 3, 5, 7. So it was 3, 5, 7. Then we just check that that is 3 squares. 3, 5, 7. And that gives us a 3, 7 slash square there. That gives us a 3, 7 slash square there, which means the 5 must be there. Another one with quite a lot of numbers in it. 2. Sorry, I'm doing it the wrong way. I should be saying the number that's not there out loud. Right. 1, 3, 5, 9. 1, 3, 5, 9. 1, 3, 5, 9. 1, 3, 5, 9. 1, 3, because the 5, 9's there. 1, 3, 5, 9. Yep, 1 there. So this will be 3, 5 because of the 9. Doesn't matter which way round they are. And that's it. Yep, you might be neurotic and want to put them the right way around, but because we've put the 5 in the top left corner, we're doing 5, 3 for that instead of 3, 5. Let's find some more with lots in there. This is interesting because you've got a pair of 2s there, which means they're taken care of for the purposes of this square. So again, well, actually they are there again, and there, but it's just a feature to think about. In fact, let's look at this one. Let's look at this one now, because you've got 1, 3, 9. 1, 3, 9, and there's the 9, so that's 1, all 3. Now we've got, this is excellent, 1 and 3 for these two squares. So 1 and 3s are done for this column, and they're also done for this box. So therefore we can go 2, 9. Yep, 2, 9, 2, 9, 2, 9. That gives us 2, 9 for this row. And there's 9s here, so that 9 will have to be up there because those 9 in that row there. and so there couldn't be a 9 there because it messes with that. So now we perhaps could look at that square again in a minute, but I'm going to look at this row because we've got 2929. That covers the whole row. So we do it again. 3, 6. So what did I say? 3, 6. So this is a 3, 6, and this is a 3, 6. Bit hard to see that one. Interesting. 3, 6, 5, 3. So obviously 5, 3, and 6 are the missing numbers from these three here. This square could be any of the 3. Let's just look for another row with lots of numbers in it. This one's not too bad. 5, 7, 8, 9. 5, 7, 8, 9. 5, 8, so that'll be 7, 9. 5, 9, so that'll be 7, 8. 5, 7, 8, 9. That's it for that line. Just looking at the line. Oh wait, look, there's a 5 there, and there were 2 5s there. So that 5's there. What does that do? That doesn't help us there, but no, because that's solved. 5, 5. Ah, look, 5, 5, and that 1 gave us that 5, and then that 5, 5, and that'll be in the middle there, so it'll be one of those 2. So we can put the baby ones in. We've got another square there. Look, 5, 5, 5, 5. So once we solve one of those 5s, the next ones get knocked out immediately. Remember, we said that with the 2s here. Same thing, same idea. There's a square that's fairly full up, and the 4s are taken in those. So we could look at this one here. 3, 7, so 3, 7. Just quick check up here. It looks like we can't eliminate it further, but we can put in our slash square. So we've got 3, 6 there, 6, 7, and 3, 7. Again, we're looking for a pair. If one of those was a pair that matched, then the remaining square would be the remaining digit of the 3. So if it were 3, 7, and 3, 7, then we'd know that the 6 would be in that one. If it was 6, 7, and 6, 7, we'd know that the 3 would be in that one. That's how all that works. So again, we look at these little slash. We do look at these little slash numbers. You know, 2, 9, 2, 9, 3, 6, 3, 6, and you're looking for where you might have a matching pair. And that will take those pairs away from that line, leaving us with the remaining digit usually. Again, what we've got here, we can just look at the pairs now to see what the missing numbers are. It looks like it's 7, 8, and 9 there. 7, 8, and 7, 9. So 7, 8, 9. So here we've got a 7, 8, or a 9. But it looks like we didn't whittle it down further. What's happening with these 4s here? What did we say? 3, 4, 7. So this is 3, 4, 7. No, these 3s and 7s really need to be looked at. So let's start looking at the 3s and 7s. I don't want to have to start doing hypotheticals. That's where it gets really difficult. But that is the stage you get to eventually, is the hypothetical stage. You're getting a bit stuck here now. This is a good moment to ink in the ones we're certain of already. So I'll do that now. It's also a good moment to put the kettle on and have a cup of coffee. And then go away and come back to it. And you'll be amazed. You'll be amazed what you see when you come back to it. Things will just jump straight off the page at you. And you'll see straight away, my word, how did I not see that? 1, 3, 5. What's the other number that's missing from that lot there? We've got 1, 3, 5, but there's actually 4 squares in that line. So there's only 3 numbers up from here. We've got 1, 3, we've got 5, 3, so that's 1, 3, 5, which means there's a number that only goes in one of those 2 squares. What is it? So let's work it out. It's the 9. So we've got a 9. Just more information. Just more information. Doesn't give us any slash pairs, unfortunately. Found something. I have found something. I was looking at these 1, 3s here and thinking to myself, well, that means that we can go 1, and we know it's going to be one of these 3, so we could do our 3 here. We do our pool cue again, can't we? It's here. that one's there, that one has got to be there, so this one will have to be here. And look, we've got 1, 1, and so we've got the 1 there. I'm going to get with black ink immediately. And there's also got a pair of 2s there, which means that the 2 goes there. We've got a 2, 9 there, so that's going to be the 9 of the 2, 9. And that's going to be the 2 of the 2, 9, because that was also a 2, 9 there. There's a 7, 9 there, so that 7 is inked in. And there's a 7, 8 there, so the 8 is inked in. See how many? That's like a house of cards just falls. And now this, look at this column. 3, 4. So it's 3, 4. 3, 4, and 3, 4. So it looks like it doesn't give us an actual number, but it gives us a slash square, 3, 4. And it gives us a 3, 4 there. What else has that given us? We've got 3, 6 and 3, 6 there. They were already sitting there like that. And the 2s are done, I think. Yep, the 2s are completely done now. 9, 9, and then a 9, and the pair of 9s up here. That gives us, let's just put baby 9s in there. Gives us the pair of 9s there. This row's almost done. Looks like it only needs that 9. Pop it in there. This is why you get these slash squares going on. Did you see how many of them just collapsed like a house of cards there? So we've got this block of 1s here. Again, a square. We've got a square of 5s here. We've got a square of 1s here. And we had the square of 2s here, remember? So I said they would go diagonally if they went. So these squares, while they're great if you solve one of them, they're very unhelpful if they're just sitting there, because they are totally unsolvable until you get one of them. They just remain totally insoluble. This line across here, 3, 4, 6, 7, 3, 4, 6, 7, 3, 4, 6, 7, 3, 4, 6, 7, 3, 4, 6, 7, 3, 4, 6, 7, no. 3, 4, 7, 8. No. That's 3, 4, 7 there. No, yes it is. Look, I know it's a 3, but okay, I'll show you what I've just come up with. So at this line here, we've got we've got these pairs sitting in here. You want to look for where you've got lots of these pairs, because they can give you helpful information. They exclude. So we got 3, 4, 7, 8. So 3, 4, 7, 8 is our numbers here. Looking down here, it looks like it'll only be the 3, 4, and the 7 because of the 8 there. So let's just write them in for a second. We wouldn't normally write them in, but 3, 4, 7, 3, 4, and 3, 7. So the 8's got to be in that one, because that square, and that square only have 3s, 4s, and 7s in. So the 8's there. So that's why we do that. This is why we do slash squares. 8, 8, and that gives us an 8 there, gives us a pair of 8s. I mean, we're back to the drawing board again now, but not quite. Not quite. This row now might be more interesting. It might not, but it might be. 3, 4, 6, 7, 8. 3, 4, 6, 7, 8. Of course, the 8s are there. 3, 4, 6, 7, 8. 3, 6. Oh, yeah, that's the 3, 6 then. Because the 4, 7, and the 8 are in that column already. So that's a 3, 6. Interesting. 3, 4, and that's a 3, 4, 7 again. What's this? 3, 4, 7. That's a 3, 4, 7 as well. Yeah, so we've got 3, 4, 7, 3, 4, 7, and 3, 7 in this square like that. 3 numbers for 3 squares, but it's not in a row, so it doesn't help to find one further down that, that's knocked out through that. We can't do that with that trick there. But that's the kind of trick we're trying to do. But the trouble is, we've got some of these squares, you know, we've got ones in squares like this. And we've got fives in squares like this. These are the ones we want to get knocked out rather urgently. And we've got lots of pairs here that if we were to get one number, it starts another pair cascading. This square really does look like it could be helpful, but I can't quite see how at the moment. We've got 1, 3, 5, 3. I don't think we can do it though. 1, 2, no, sorry, 1, 3, 5, 9. 1, 3, 5, 9. 1, 3, 3, 5. 1, 3, 5. Ah! That 9 knocks that one out, gives us the 9 there. So it was worth looking at all those numbers. Gives us the 9 there, gives us the 1 there. What do we have? 1, 3, 5, 9. So that becomes a 3, 5, we said, didn't we? It becomes a 3, that's a 3, 5. Let's not get ahead of ourselves. That's a 3, 5, that's a 3, 5, which means the 1, 3 is there. Has to be the 1. It's all going to come out. That means that 1, 3 has to be the 3. Five, 3, 3, 6, 3, 5, 6, 3, 5, 6, 3, 5, 6. That'll be a 5, 6. That'll be, no, it doesn't give us anything, but it, oh no, it does, because it gives us a triptych of numbers. So we've got 3, 5, and 6 in those, which means that the rest of this line can't have 3, 5, or 6 in. So we can count, for the sake of argument, that 3, 5, and 6 are missing. And we've got 1, 2, and 9 missing as well. 1, 2, and 9. So that leaves us with 4, 7, 8. 4, 7, 8. So 4, 7, 8 there. Can't whittle it for 4, 7, 8 there. 4, 7, 8. So that's 4, 7, 8. But this is bound to come out now. 5 and 6 there. So that's a 5 and 6 there. We desperately need a 7 to just knock out somewhere. What's going on up here? 4, 6, 7. 4, 6, 7, 4, 6, 7, 4, 6. Oh, so that's a 4, 7 now. And that's a 4, 6. Because of the 7 there. And that's still a 4, 6, 7. 3, 4, and 3, 6. So the 7 is in that one or that one. We got the 1. We're edging nearer to finding these elusive 7s. 3, 6 there. Nothing can be excluded there in the ways of 3s and 6s. No, it can't. So again, this one, 3, 6, and 9. So that's the 9s up there. Speaking of which, 9, 9, and 9. No, it's not going to knock out yet. Yeah, it looks like we've got a square of 9s as well. A lot of squares in this one. 9, 9, and 9. Yep, a lot of squares. They're too complete, unfortunately. We're waiting to find the card that's going to cascade it. Being the, what if that's a 6? Let's look at this one down here. We're looking at this 3, 6 down here. We'll start with the 3. 3, 3, then that makes that be the 3. 3, 3, then that 3 comes down here. 3. No, it doesn't really eliminate anything, but let's try to make it be the 6 then. 6, 6, that makes that be the 6 up there. 6, 6, that makes it be the 6 there. 6, 6, that makes it be the 6 in the middle. 6, 6, that makes it be the 6 there. 6, 6, that makes it be the 6 there. 6, 6, that makes it be the 6 there. That actually works. I think it's likely that that 3, 6 is the 6, because it comes together very cleanly. But it is not conclusive. So instead, what I decided was that there was a lot of numbers where we've got squares, and the numbers are making it very difficult. You know, the squares, 5, 5, 5, 5. The squares quite often are not solvable until you find something that's jigged off from being a square that's solvable. So I'm looking at this pair of 6, 7 and 6, 7 here that is not a square. They're not going in a big square to be solved. And I thought, let's do an if on this. Let's do if this is 6. If this is 6, then this becomes a 7. If this be a 7, then it's 7, 7, and that must be the 7 there. But look, there's already a 7 in that column. So therefore, this cannot be a 6. I'll go through the logic one more time for you. If that's a 6, this must be a 7, because 6, 7, 6, 7. If that's a 7, it's 7, 7, 7, and there's a 7 down there. So that cannot be a 6. It can only be a 7 because it's a 6, 7. So we got that 7 there, and we got that 6 there. So let's just try and remember that we've done that 6 and 7. Let's just put them in black, actually. Try and remember we've done those, because now we need to look at everything around those 6s and 7s to see what it helps us to solve, because it could well solve the entire puzzle. It was the only jiggled one that I could find. You see, it's a chess move, it's a knight's move. 7, there's a 3, 7. That's what we want to look for. There's a 3, 4. There's a 4, 7. 4, 3 up here. Six, 6, that makes that 6 be in there. There's a 5, 6 there for that square. There's a 5, 3 there for that square. 5, 6, 3, 6, 5, 3. The whole centre block is done. That says 4, 6 at the top there, so I'm assuming that's 4, 6 at the bottom as well. So we've got the 4 there, so that must be the 6. That'll be the 4. And a 6, 6, and then we're going to have a 6 here. It's going to be that one. Knocks out that pair of 8s. Knocks out... did that knock out something else? Did it knock out a 7 or something? No, maybe it didn't. I think we'll have enough. We don't need to worry even about having missed something. 3, 6, there's a 6 there. That square's complete now. Looks like it's going to be 6 and 9 here. There's a 6, there's a 9 goes there. 6 goes there. 9 gives us the 8, 9 there. Gives us the 8, 9 there. These squares you see are now knocking out. This 4, 7. 4, 7. It's not there, but it'll come. Got another 4, 7 there. Got a 3, 7 there. So it's 4, 3, 7 that row. If that row is 4, 3, 7, there's a missing number here that is not one of those, which is the 8. 8 coming down here leaves only 2 numbers, 3 and 4, I believe. 3 and 4. So that'll be a 3, 4. That'll be a 3, 4. So I'm doing black ink. I'm being lazy now already. Got 3, 7 and 4, 7 there, which makes no sense. 3, 7, 4, 7, 4, 3. Didn't I say it would knock out quickly? As soon as that cascade started, as soon as we found that chess piece, that chess move, and solved it, the whole thing just fell like a house of cards. So that's how you do these hard Sudokus. That one was rock hard, but we got there. We got there with forensic checking and looking, and cups of coffee, coming back, and magnifying glasses. And that was the Metro from February the 20th, 2025.